All right, so we're starting with 3.1 today, measures of central tendency. First thing we're looking at is the mean. Mean is another word for average. In statistics, very rarely do they use the word average. Normally they use the word mean. Like I said, it's the same thing as the average. Find the mean, you will add all of your data values together and then divide by the number of data values that you have. All right, so our first example, just a mini example. If we have the data set of 1, 2, 3, 4, 5, you will add up 1, 2, 3, 4, 5 and divide by 5 because we have 5 numbers. So it's 15 over 5, and that makes our mean 3. Once again, a reminder, especially since I have these notes already written out, if I move too fast, let me know, or or if I start to scroll up and you would like for me to come back down or re-explain anything, please let me know, because of course, remember, I can't see most of you, so I don't know if you're still writing or not. All right. Next one is our median. When you think about median, you can think about middle or middle value. So the first thing we'll do when we're trying to find the median is we're going to list all data values from least to greatest. Please don't forget that step because a lot of people do. List all your data values from least to greatest. If the number of data values is odd, take the middle value. And then if the number of data values is even, take the mean of the two middle values. In other words, the average of the two middle values. So you add the two middle values and then divide by 2, and that will give you your mean. All right. So here, for an example, we have two data sets. First data set, 1 through 5, like I did before. 5 numbers. So we have odd number of data values. So that means our mean, or not our mean, excuse me, our median will just be the middle value, which is 3. All right. So now in the second set, we have 1 through 6. So we have an even number of data values. So what we would do is we would take the two middle values, which is 3 and 4, add them together, and divide by 2, and that'll be 3.5. And notice that 3.5 goes in the middle of 3 and 4. So looking at this last statement about the median will separate the data into halves. All right. Now your mode, you can think about most. We talk about your mode, the data value that appears the most frequently will be your mode. It is possible to not have a mode. It is possible to have more than one mode. And most of the time, when we talk about having more than one mode, you have a larger data set. Bimodal is having 2 modes. Multimodal is when you have more than 2. right. So here we have the data set of 12789675297651347. And so our mode would be 7 because it appears the most. All right, questions? Any questions? All right, so one last statement. All of these were summaries of data. Your mode, whether it be your mode, mean, or median, they summarize your data set. So it says a summary of data is said to be resistant if outliers, in your definitions, and we talked about it last class, should have come across the term outliers. They're just extreme values, very extreme values in comparison to your data set. So they're either very, very large values or very, very small values, once again, in comparison to the data set that you have. So if outliers do not affect your summary of data, they're considered to be resistant. So what do we mean by that? I'll give you a chance to write that before I go up to the examples. All right, so the data set of 1, 2, 3, 4, 5, we've already found the mean and the median. Mean is 3 and the median is 3. But let's say we have the data set of 1, 2, 3, 4, 500. So I changed the 5 to 500. So in comparison to the data set, that 500 is an outlier. So if we find the mean, add those 5 data values up, get 510, then divide by 5, that gives us 102. So the mean changes according because it have this outlier that now exists. But if you check out the median is still 3. So your mean is not resistant to outliers, but your median is or will be resistant to outliers. Outliers do not have to affect the mean. The outliers do not have to affect the median. Outliers will always affect your mean. Outliers, whether very large or very small, can make your average go up or go down. Questions on what it means to be resistant to outliers. No, that's the statement right there. This means the median is resistant to outliers. All right, questions before we go into 3-2? All right, 3.2 measures of dispersion. Dispersion is the degree to which the data is spread out. All right, first thing they mention in this section is your range. So your range is just the largest value minus the smallest value. So going back to our data set of 1 through 5, if I wanted to find the range of that data, I would do 5, which is the largest value, and subtract 1, which is my smallest value, and that will give me 4. All right, your standard deviation measures how far a data value is from the mean. And then your variance is going to be your standard deviation squared, and it's just another way to measure the spread of data. All right. All right, so as far as the standard deviation and the variance, this book doesn't necessarily focus on the calculation, but the application. So I won't hold you to knowing how to find the standard deviation or the variance, but you will have to find an application or app calculator website or something of that nature that will help you to calculate the standard deviation and the variance. All right, so one I always suggest is easycalculation.com. It's something that I know works, and I'll show you that in a second. Or you need something, app, calculator, website, or something of that nature. StatCrunch, we talked about, or I mentioned StatCrunch in your My Math Lab Help toolbox. That's something that if you want to use, would help you find the standard deviations as well, and the variance. So you need something reliable. And so I just gave you a data set that you could try. And so let me go to that 62. Show you this real quick. So all I would do is easycalculation.com, standard deviation, and you guys making sure you guys are seeing my share screen. And hit enter. And so that's the first one that pops up. And also make sure you pay attention to the directions of whatever app or website you decide to use. Some will say separate by commas like this one. Some will say separate by space or colon, semicolon. So it just depends. So our data set was 62, 88, 77, 68. So all you do is type it in and separate by comma, hit calculate. And there it goes, standard deviation and variance. And notice it mentions down here population standard deviation, population variance. So in a second, we're going to talk about notation and how you have to pay attention to the notation and pay attention to the words in the problem. Normally, if you only have 4 values, that would be a sample. So the difference between a population and a sample, if you're talking about, let's say, TCC student body, the whole student body would be your population. This class would be a sample of that population. So a sample is just a piece of the whole group that you're dealing with. And the population would be that whole group. So the standard deviation and variance of the sample would be a little bit different than the sample and than the population standard deviation and the population variance. Formula is slightly different. All right. All right. So questions on that before we go a little further? All right. So here's your notation. So in statistics, you will have different notation for your population than you will for your sample. Now, X will always represent your data value, whether you're dealing with population or sample. That's the only thing that's going to be the same. But here we have Greek letter mu, and it kind of looks like a U with an extended stem on that left side. You'll know it when you see it though. Greek letter mu, and that's your population mean. Then we have the lowercase sigma. So you would just call it sigma, but the only reason I say lowercase because we have capital sigma over here to my right, which represents summation. So if I had sigma x, that means you would add up all your data values. So that's the sigma that most people are accustomed to seeing. But this other one is sigma as well, but it is your lowercase sigma. So that's your standard deviation for your population, and then sigma squared is your population variance. They go, oh, like this. And just rewrote like that. So next time, people won't think it's actually lowercase sigma. His name is sigma, but it's the lowercase. Anyway, that was just me rewriting my notes. So, oh, also capital N is your population size. All right, going down a little further, then we have our sample notation. So X bar, any variable with a bar over it, you would just say that variable bar. So just like if we have Y bar, you know, be the bar over Y, or if we have A bar, you know, B bar. I mean, normally we don't go that far with it, but any variable with that bar over it, you would just say that variable bar. And then regular S is your sample standard deviation. S squared is your sample variance. And then lowercase n is your sample size. So if you see any of those, then you know you're dealing with your sample versus the previous ones. If you saw any of those, you would know that you're dealing with your population. All right, any questions? All right, so you have one more thing out of 3.2. All right, so our empirical rule. So we have 3 statements here. You got the first 2 up right now. I'll scroll up for the third. APP approximately 68% of your data is within 1 standard deviation of the mean. Then approximately 95% of your data is within 2 standard deviations of the mean. All right. Then our third statement, approximately 99.7% of the data is within 3 standard deviations of the mean. All right. So here's a diagram that represents that. Let me erase some of this stuff. All right. So we're going to use this diagram in the next problem. And notice we have our bell-shaped curve here. Remember I told you that was going to come back up. And like I said, remember the shape of this curve and the details of this curve, because we will be using it throughout the whole semester. But this is your normal distribution. Here we have the mean that's in the middle. And these percentages is the breakdown of 100%. Your mean is in the middle. Remember, your normal distribution is reflection, symmetric about the mean. So 50% is on the right, 50% is on the left. What's going on the right is going to go on the left as well. So within 1 standard deviation, see if I can erase this without erasing my line. All right. So within 1 standard deviation, you're talking about adding a standard deviation and subtracting the standard deviation. Is 68% of our data. So you see 34 on the right, 34 on the left. 34 and 34 will give us that 68%. Then adding another standard deviation and subtracting another standard deviation puts us here. And that's 95% of our data. So you're adding 13.5 on both sides as far as our percentages are concerned. And then adding 2.35 as far as percentages are concerned on the right and left gives us 3 standard deviations out, and that would be 99.7% of our data. And notice on the tails, you have 0.15%. That 0.15%, adding them up, that'll give you 0.3. And then 0.3 plus that 99.7 will give you 100%. So like I said, this is a breakdown of 100% of your data. And using the empirical rule, going out 1 standard deviation, right and left, 2 standard deviations, and then 3 standard deviations. So after you copy it, we'll put an example to it and see what all that means. All right. So let's look at this last example for today. The mean IQ score of students enrolled at University A is 100, and the standard deviation is 16.1. So they give us the mean and the standard deviation. It says determine, DT was just me shortening up determine the percentage of students who have IQ scores within 3 standard deviations of the mean according to the empirical rule. B, determine the percentage of students who have scores between 67.8 and 132.2. We also have a C. All right, so C, determine the percentage of students. Is that what it is? Who have scores above 132.2. All right. So they give us the mean and standard deviation. Our mean is 100. Standard deviation is 16.1. So I'm calling our mean using population notation. So mu and sigma. You know, if we were looking at sample, then we'd be using X bar and S. So that's the only reason I wrote those right there. Just reiterating the notation. All right, so when we look at calculations, just going back here, we have a right side of our empirical rule, left side. So I'm going to calculate the right side. Notice what you would do is just add a standard deviation 3 different times. And then for the left side, we would subtract our standard deviation 3 different times. And we're subtracting it and adding it from the mean. So when we look at the right side, I have 100 plus 116 plus 16.1. So that gives me 116.1. And then add 16.1 again, that'll be 132.2. Then add 16.1 a third time, and that'll be 148.3. So that's the right side of the empirical rule. Left side, you're going to subtract 16.1 from 100. So subtract 16.1, then subtract it one more time, then subtract it a third time. That'll give us 83.9, 67.8, 51.7. So this will always be the process. You have your mean, you have your standard deviation. Take your mean, in this case was 100, add a 16.1 to get the first one, add a 16.1 again to get the second one, add 16.1 again to get the third one. And then on the left side, you're going to subtract 16.1 3 different times, and you will get your 3 values. Make sure we're all right. All right. So now as far as filling out the empirical rule chart, so those percentages, like I said, stay the same. Where we would start is 100 is in the middle, that's our mean. And then to the right, 116.1, 132.2, 148.3. And then to the left of your mean, 83.9, 67.8, 51.7. And once again, those percentages, the 34, 13.5, 235, and 0.15, those all stay the same. Those will never change. All right, make sure we don't have any questions. All right. So almost finished. So the first question, looking at letter A, it says determine the percentage of students who have IQ scores within 3 standard deviations of the mean according to the empirical rule. Now we didn't necessarily have to do all that calculation to find letter A. Going back to the empirical rule, approximately 99.7% of the data is within 3 standard deviations of the mean. And that's all they were asking. It says according to the empirical rule, you know, how much or how many how much of the IQ scores do we expect to be within 3 standard deviations of the mean? So that's just going to be that 99.7. So that's where that came from, just from the empirical rule. All right. So B, determine the percentage of students who have scored between 67.8 and 132.2. So you would go to your chart that you've already filled in and, oh no, hit the wrong one. Let's go back. All right, there we go. So we look at 67.8 and 132.2 and add up your percentages. So you have 13.5, 34, 34, and 13.5 between 67.8 and 132.2. Add them up, you get 95%. And they could have asked you any of those numbers and you would have been able to just add up the percentages and know what to expect between those values. So it's something that you could use, you know, to predict weather patterns and all the stuff like that. And all of it is based on previous observations. Last one, C, determine the percentage of students who have scores better or above 132.2. So you go to the 132.2, and which is right here, and you're talking about values that are above it. So you would add up the percentages of 235.5 with 2.35 and then the 0.15, and that gives you 2.5%. All right. Questions on that? All right. So I know we have more time left in class, but I'm not going to rush chapter 3. Try to give you guys a chance to get out of chapter 1 and 2. Don't forget those assignments are not due, but are in my math lab. Make sure you're doing your homework. Chapter 3 is only 4 sections. You're not held responsible for section 3.3. So notice the next one we get into is 3.4. So next class we're looking to close out 3, 4, and 3, 5, and really we'll be done with chapter 3. So that's why I said make sure you're doing this stuff and get it done as quick as possible, because the next thing you know we'll be done with chapter 4. Chapter 4 is only 3 sections. So, and I'll try to extend that out as long as I can, as far as being reasonable. But yeah, so this stuff can fly by quick. Next thing you know, you'll be in chapter 6 or something like that. So make sure you're staying on top of your homework and you're getting the easy stuff done. Like I said, chapter 1 and 2 are based on definitions of graphs. You want to get that easy stuff done and out of the way before we really get into concepts and calculations that may give you a little bit of a speed bump or slow you down a little. So outside of that, any questions before we close out? All right. So with that being said, you guys have a great weekend. Be safe. Just like last week, I'll be posting this video shortly, and you'll have it to review.
Oh, excuse me.
Yep.
So, what about the assignment 1 and 2? A definition?
I haven't. Those are coming out of chapter 3, and you're talking about in my math lab, right? I have those 5 like problems.
Yes.
Yeah, we'll talk about that next class.
Okay. All right.
Yep, we're gonna cover those topics on next class, and then I'll give you those few problems to practice. I mean, if you want to knock it out early, you can, but they're not due or anything yet.
Okay. Thank you.
All right. Thank you. Thank you.
Mm-hmm.
Thank you.
All right, you guys have a great weekend. Be safe. I'll see you on Monday.
Thank you. Have a good
Bye.
All right, take care.